In this video, we're solving exponential equations, and we'll use logarithms a lot to do this. So for example, we've got this one, 2 to the x is 20. So you might list out some powers of 2, for example. So 2 to the 4 is 16, 2 to the 5 is 32. And if you sort of look, 20 is in between 16 and 32. So maybe 2 to something like 4.2 might be 20. Something around that range might be the right answer. Now, the formal process for solving this equation is you might want to log both sides. Now, it doesn't actually matter which base you use at all. I'm just going to use base 10 because that's sort of the standard. Technically, it's a little bit quicker if you use base 2, but some calculators don't have a base 2 button for log. So we just use log base 10. Next step here will be to pull x out the front. So you get x times log of 2 is log of 20. Now, this is just the log laws. Specifically that third one where powers can come out front. And so x is log of 20 divided by log of 2. So it roughly equals, and we can figure out an approximate there. So log of 20, I might do it in fraction mode. Log of 20 over log of 2 is about 4.32. So our guess of 4.2 was actually pretty good. Okay, we have this equation. This is a little bit messier. We're going to rearrange it first. So 2 times 5 to the x is 50 take 3, so 47. Therefore, 5 to the x is 47 over 2, so we halve it. And then we log both sides. So log of 5 to the x is log of 47 over 2. And so you can pull the x out the front. So x times log of 5. This is just your log law there. And this is log of 47 over 2. And then we can divide by log of 5. So x is log of 47 over 2 all over log of 5. And I guess you could get an approximate for that in your calculator. So if we do that, we're going to have log of 47 over 2 all over log of 5. And we're going to get 1.96. And it's always good to double check that you've actually done this right. So if I do 3 plus 2 times 5 to the power of that answer we just got, 1.96, I should get about 50. Because we've rounded the x value, I don't get exactly 50, but you can see 49.8 is pretty much 50. Okay. This is some real world data, ChatGPT. So it starts with 1 million users, and just based on the first sort of year or so of its growth, it looks like it's getting 100 times the users each year. So November 2022, we got 1 million users. So 1,000,000,000, and we're going to have 100 times the growth each year. So after 1 year, so this is in November 2023, we have 2 more zeros, so 100 million. And really all we've done there is times it by 100. So we'd like to get an exponential equation. Remember, all exponential equations sort of look like this: a times b to the x. A is the starting amount, so that's going to be the 1 million that we started with. And then we're going to be timesing it by, every year we're gaining 100. So that's just what the equation looks like. But we're going to have, I might go capital U for users. That'll be a function of time. This is 1 million times 100 to the power of t. So that's just using like the proper letters and everything. So how long does it take to reach 1 billion users? Okay. So there's sort of 2 ways you can do this. So we can go into our graph and we can sort of look at the users. So 1 times 100 to the power of x. If we look at this and go on our window, we're going to go 0 to 5 years maybe. And then we're going to go 0 to, these numbers are going to get really big. So I'm just going to do a whole bunch of zeros. And we can sort of see the exponential graph going there. A few key values. If we trace at 0, you'll see it's 1 million. And if we go and trace at 1 year, for example, November 2023, you can see that it's 1 with 8 zeros, which is what we put. So the way we can figure out this is we can go xcal and we go y is 1 billion. So that's 1 with 1, 2, 3, 4, 5, 6, 7, 8, 9 zeros. And it appears to take 1.5 years. So that's from the calculator. But we can solve this by hand. So by hand, we've got to set u equal to 1 billion. So 1, 2, 3, 4, 5, 6, 7, 8, 9 zeros. And this is going to equal the original equation times 100 to the power of t. And then we can just divide by that original equation. I think I need one more zero in there. I can divide by that original amount. So we got 1 with 9 zeros, all divided by 1 with 6 zeros, equals 100 to the power of t. Now, the short answer is this is 1,000. But if you want, you can think of this as 10 to the 9 over 10 to the 6, which you would get 10 to the 3. Okay, so 1,000 is 100 to the power of t. We then need log of 1,000 equals log of 100 to the power of t. And then we can work that out. In fact, t comes out the front, log of 100 and log of 1,000. We can divide by log of 100. So we're left with t over here, and we get log of 1,000 over log of 100. These, because we're in base 10, are actually really nice numbers. It's just 3 over 2. And then, so that's t is 1.5 years. That's just the nature of exponential growth. You start off with 1 million, which is quite small compared to 1 billion, and before long you're at 1 billion. Exponentials grow quickly. And you can see this is what the calculators said as well, 1.5 years, which matches our value from by hand. So we're going to repeat the same process for 1 trillion users. So this has 12 zeros. So I might just go u of t. This was 1 times 10 to the 6 times 100 to the power of t. So this was 1 million there. And this here is 1 times 10 to the 12. So I'm just putting these in scientific notation to make it easier. But 1 times 10 to the 12 is 1 times 10 to the 6 times 100 to the power of t. So you're going to get basically 10 to the 12 over 10 to the 6 here, 100 to the power of t. And so that's 10 to the 6 is 100 to the power of t. So we're going to get the log of 10 to the 6 is log of 100t. So if you rearrange that, you can pull t out the front. T log of 100 is log of 10 to the 6. And then t would be log of 10 to the 6 over log of 100, which is 3. So t is 3. So it takes 3 years to reach 1 trillion users. And if we look at the graph that we got here, so what I can do is gsolve xcal. I might just go 10 to the 12 for 1 trillion, but you can see that x is 3. So that's how long it takes to get there. There's a follow-up question here. Is this realistic? The answer is no. We don't have 1 trillion humans. So most likely what the graph would actually look like for ChatGPT users over time is something like this. I think I talked about this briefly in a previous video, but this is called a logistic graph. And some limiting value there. This would be the limit. And this is the population with access to computers. And I guess you could say it's like whether or not they have interest in the computers as well. So I don't know what the population is at the moment. It's in the low billions. But yeah, you're never going to hit 1 trillion because you don't have 1 trillion humans to use ChatGPT. So you've always got to consider the reasonableness of your results as well.